Hello, friends. The age of intelligent machines is here. Machine learning is becoming more and more ubiquitous. These machines will be your colleagues at work, will be your assistants at home. They'll help you predict your business processes, troubleshoot them at work. If you're a manager, they'll help you rate employees based on a lot of parameters. At the end of the year, the employee rating. Or if you're a dean of university admissions, they'll help you find out which students are likely to succeed as graduate students for a program, for a graduate program. As assistants at home, they will, hey, make me a plane, what time's the best time to reserve plane tickets so that I don't get the middle seat on my vacation flight, which is kind of long? Or set the thermostat to the ideal value for me. These machines are going to make your life easier and better and richer. It will require, however, that we democratize machine learning or to realize that vision. Machine learning must not be a preserve of a tiny community of data scientists. It must be freed from that and be made accessible to the people at large so that each one of you, irrespective of whether or not you're schooled in the theory of statistical rigor, can use these machines to predict your world. And that's exactly what EazyML does. It predicts your world while democratizing it so that you can do it yourself. How does it do that? Well, makes it easy to use. It makes it do it yourself. You don't have to read an owner's manual to get started to building intelligent machines that predict your world. There's one big requirement for making it easy, machine learning easy to use and do it yourself, and that is transparency. What the heck does it mean? The machine must explain why it predicted the way it did so that you can trust it, so that you can rely on it as a trusted confidant that does right predictions for you. It must explain how it's processing your data step by step, it's building your predictive models to predict your world, so that you feel comfortable with it. It's not a black box, God knows what it did underneath the hood. You actually start to appreciate. And above all, the pricing must be affordable so that it doesn't burn a hole in your pocket. No gotchas, no hidden fees. Well, seeing is believing. Let's see how EazyML democratizes machine learning so each one of you can benefit from intelligent machines to predict your own world. Fairly simple to get started. Pick your favorite browser. In this case, it's Google Chrome. You'll get a login. Just log right in. In this case, I'm logging in using my Google account. And you get the product liability disclaimer, blah, blah, blah. Of course, you say yes to that. You hit proceed. And there we are. EazyML is at your service. First question it asks is, do you want to go accelerated or detailed? So a couple of navigational points here. Number one, the machine gives you a default recommendation based on statistical rigor. You suggest you just follow. You can certainly override it, but we recommend that you allow the machine to proceed the way it's recommending because it's based on sound statistical theory. For the curious mind, you may want to hit the help button to see what the hell does it mean? What do you accelerated versus detailed? What does that mean? Well, there we go. Hit that, and it will tell you it's a transparent machine. Nothing's hidden. Oh, so these are for the impatient guys. Don't want to see the details. Just give me the final product. Thanks, but I don't want to see step by step here. you're very welcome to do the accelerated mode. The curious mind will follow the detailed mode. No, show me, I'm curious to know how the machine goes about building intelligent statistical machines that predict my work. Because we are doing a demo, for the purposes of illustration, I'm going to follow the detailed mode. So the next couple of minutes, you'll see the machine in action. All right, so hit the next. Okay, so here we are. We are on with the ML exercise. 3 steps, simple. You upload the data, training data. After all, the machine needs to be trained, right? Before it can start predicting your world, it needs to understand your world. And the training data makes it understand your world. Then it will build models based on what it's understood about your world, and then use that to predict your world. 1, 2, 3, as simple as that. So what does the training data look like? Very, very simple, just an Excel spreadsheet. So let me show. In this case, we are exploring a use case that is for employee rating, which means at the end of the year, fiscal year, you get your rating, which determines your raises in many cases. So various input parameters, variables, or predictors, as we call them in statistics, in machine learning. And then the final output is, or outcome as we call it, is the rating of the employee. What are the deals he worked on, whether they were timely delivered, the value of those deals, what were the customer feedbacks, is he a team player, how responsive is it, and so on and so forth. And last is column P, is what was the rating of the employee? Was it good? Was it satisfactory or poor? You've got, I'd say, about 250 rows here. You can see that in your training data. You can do with as little as 100 maybe. The more the merrier, because the machine learns your word better. But so, all right, so let's proceed now. We'll upload this training data, this file. So I'm going to hit next. I'm going to choose the file, and bang, it's uploaded it. All right, it says 250 records and 16 predictors, and you can actually scroll through it and see, yeah, that's fine. It's all those things that we saw in the Excel spreadsheet in the training data. And yes, the last column is the employee evaluation. So the machine is going to learn, and build a model now for evaluating your employees. But before it does that, before it learns from this training data, this Excel file that you've uploaded, it must do some pre-processing steps on this data here. And so that's what we'll do over the next several steps here. Keep hitting next. You'll come across several things, and you may not know what they mean. You're very curious, hit the help button. Otherwise, the machine has made its default recommendation, like we said. Just keep hitting next, and it keeps taking you. Now it's come up with the type of data. Is it numeric, categorical, textual? It's come up with those types. And that's wonderful. Again, using statistical rigor. It's come up with some data that it thinks are frivolous, variables or predictors that do not have a lot of influence in predicting the outcome, which is employee rating. So it's identified those, and it says, I'm going to remove them. Say, yeah, that's fine. We trust you, Mr. Machine. And it keeps going on. Now it's giving you some characteristics of your variables, the min, max, standard deviation, and so on and so forth. Thank you for that. Let's keep going. Now it says, do you want to remove outliers? That means, does your Excel spreadsheet, the training data that you uploaded, does it have some rows in there that have extreme values for one or more variables, one or more columns, that can throw the machine off as it's learning your environment, right? So it says, my recommendation is if there are any extreme values, let's remove them. Okay, we trust you. Oh, hey, the training data was fairly clean. There were no outliers in there. So great, good to know. Okay, so the machine has reached a point where it's saying, I think I'm done with pre-processing. Here's what your cleansed up, normalized data looks like. And we'll be using that to go ahead and build your models. So you say, okay, that's wonderful, thank you. But before we do that, here's a mandatory requirement. Now what's that? It says, I need to know from you, this is the machine telling you, I need to know from you, what is it that you're trying to predict? Is it the thermostat setting, or is it the quality of voice on your circuits? In our case, it is the employee rating that we are trying to predict. So you've got to tell that to the machine. And you hit the next button, and it says, hey, do you want to visualize data? I urge that you do that, but we will keep going in order to save time. And lo and behold, bang, we are done with the first step, which is upload training data. It's all cleansed, normalized, ready to be used. So now, do you want to continue and build a model based on a copy of the training data that we have in our possession now? Yes, we do. It gives you some details about statistical interpretations. It's saying, yeah, it's a classification problem. You may be scratching your head. What the heck does that mean? Do not worry. Just hit the help button. And if you need more help, you hit more help button. The machine is very transparent. It's going to tell you that we are making one of the predictions of good, poor, or satisfactory based on your training data. All right, cool. All right, so see, it explains every step. You want to remove the dependent predictors. The machine recommends no. There must be a good reason for doing that, so let's keep going. You want the machine to add predictors. The machine recommends no. If you want to understand what that means, again, I implore you, hit the help. You'll get all the gory details. For the others, just keep hitting next and move along. Now it says it's going to select the core predictors from the list, which means, remember we talked about some predictors that are frivolous, that do not impact the outcome, whereas others that are core, that have considerable influence on the outcome, which is employee evaluation. And so it's making that distinction, removing the wheat from the chaff, if you will. And so good, let's keep going. And it says now we'll build models on your data. So yes, please proceed. And lo and behold, the machine started to build models. It's going to build several models for you and pick the best one. So you will see at the end of this exercise that the machine would have identified several models and their accuracies and rank ordered it and recommend the best statistical model to predict your word, which in this case is employee evaluation. And here's the answer. The models are built and ready. There were several of them: support vector machines, boosted and bagged decision trees, neural network, blah, 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 all the way down. And the one that won the race and got selected as the most accurate model is support vector classifier, right here, this guy. Kappa is a measure of accuracy for classification, and it was the highest for this guy. Again, should you be curious, please hit the help button and you will get to know all the details. All right, good. So we've got the model. Now we can go about predicting our word. See, I told you the machine's transparent. It's even telling you which predictor played how important a role. Oh, so the most important role was played by this predictor, value of deal. Makes sense, right? If you close many deals, then you're likely to get good rating. External customer feedback was a close second. Yeah, if your customers are saying good things about you, then you're like, your manager probably thinks good about you as well. A distant third is past performance and so on and so forth. So, cool. So the machine's given you a very detailed view of what it thinks are the core predictors. Okay, good. Congratulations. The model has been built. We are ready to predict your world. The last and the final step in the three-step journey. Predict the world. Do you want to continue? Yes, please. I do want to predict the world. And it says, hey, then upload a second Excel file, because the first one was training data. It had the answers, the ratings of the employees. Now upload one which has all the input variables, but not the output, because that the machine will predict. So here's the next one. It's got 7. It's a second Excel spreadsheet. It's got 7 rows, or 6 of 6 rows. The exact same headings, exact same, please. Keep that in mind. Headings of columns. See that? The same things that are used to determine the employee rating, but no column P. Column P was where the employee rating was there in the first spreadsheet. This is left blank intentionally because you want the machine to determine that or predict that now. So good. All right. So we're going to upload this spreadsheet. And hit next, upload. Yeah, so let's do that. We'll choose the file. Bang. There we go. It's uploaded and made the predictions. The prediction results on your data are as follows. So go to the very end, and lo and behold, you have predictions now. That's interesting. So column P, so it's things out of this, it's the employees, 6 employees that it was supposed to predict. A couple of them are satisfactory, one of them is good. This one's not applicable. What happened here? What happened for it to become not applicable? Oh, that's what happened. A typo in my Excel. Instead of satisfactory, as FACORI. See how transparent the machine is? It's even highlighted in blue font so that you can see why it said, I did not make any predictions because I did not understand this input value here. It had the T missing, that's why. Okay, cool. Got it? All right, next. It says, keep going. It's transparent to the point of being at fault. It now says, do you want to understand why I made those predictions? Yes, of course. That'd be nice. At least I can see what reasoning went in. And it says, okay, well, then you pick which one you want to understand. So it's got the choose button here, and you can see there are several such employees, 5 of them. Let's pick the last one because it worked on 14 deals. 13 of them on time, $22.22 million. That's quite an employee, and I wonder why he ended up being recommended or predicted as poor. So I'm going to find out why that happened. External customer feedback was why, in spite of that employee being good, ended up being rated as poor. Okay, so we must find out, is that the case? Let's see. This guy, the 5th employee, external customer feedback did him in. Yes, that's right. It is negative here. That is what caused this employee to have poor rating. That's exactly right. So I now get it why the machine rated this poor. See how transparent the machine is? This is the power of machine learning and how EazyML delivers for your work. Thank you.